Alright, today we're going to learn about complex numbers and the imaginary unit I and its properties. We'll talk about the algebra of complex numbers. The imaginary unit. Up until now, you've heard that you can't take the square root of a negative number. This is because there is no real number whose square is -1. To deal with this, the mathematicians started using a new number, the imaginary unit, denoted as I. Is defined as I equals the square root of -1. In other words, I is the number that has the property I squared equals -1. The complex number system is the set of all expressions of the form of a plus bi, where a and b are real numbers. The number a is the real part, and the number b is the imaginary part. So here we have some examples here where we have our a part, our real part, and this would be the 5, and plus 9, and 9i, and 9 would be the b part. Right? Remember, this is one number. Right? This expression right here is one complex number. Here's the second example. You can have fractions, you can have square roots, you can have any real number. Here we have a half minus 23 over 11i. The square roots of negative numbers. The square root property, square root of a times b equals the square root of a times the square root of b is true as long as a or b are not both negative. This is because we have the square root of -25 equals the square root of -1 times the square root of 25. We say that the square root of -25 equals I times 5, which is 5i. The I is written afterwards. We're going to check this because when we square 5i, we take the whole quantity, square it, we square the 5, we square the I, and so we get 25, and I squared equals -1, so it's 25 minus times -1 equals -25. So it wants us to compute the following. So here we're going to take, and we're going to break this, the first example, hey, in the exercise 1, is the square root of -9. So we're going to say that's going to be the square root of -1 times the square root of 9, which will give us I times, well, the square root of 9 is 3. Remember, you only get the principal, the positive square root. It's when you're solving for an unknown, you get the plus or minus. So we're only going to get positive 3. And so we have 3i as the square root of -9. We do the same thing for 18. We break it up into the square root of -18 is going to be the square root of -i, and then we're going to multiply that times the square root of 18. 18 is not a perfect square, so we're going to say this is going to be I times the square root of, well, it does have a perfect square. It's 2 times 9 inside of it, so we're going to say this is going to be I times, that's going to be 3 times the square root of 2. So we took the square root of 9, which gave us 3, and the square root of 2 has to stay behind, so we're going to get that going to be 3i square root 2 is one way you write it. One way I tell students to avoid writing it is 3 and then the square root of 2 and then I. While this is valid, sometimes when you're inputting your answer into courseware, you can accidentally still have the I underneath the radical, and you can't see it, so it's a very thin character. So I always avoid and tell students to make sure if they're going to write it behind the square root, it's not underneath the radical, because it's really easy, because I is so tiny on the screen, you may stick it under the radical, and you'll put that answer in, and then it'll say it's wrong, and then it'll show you this answer, and you'll be like, that's what I put in. So be careful of that. Also, make sure you don't accidentally put it in the root spot right there, the index spot for the root as well. So that's how typically I write it. Here we have negative square root, and I'm going to break that up into, negative square root of -17. So it's going to be negative square root of -1 times the square root of 17. 17 doesn't have any perfect squares in it. It's prime itself. So we're going to say this is going to be negative square root of, well, let's say it's -i square root of 17. That's how I typically write that. Arithmetic operation. Arithmetic operations. We have defined I in terms of a radical, so we can use what we already know about working with radicals. For adding and subtracting, we can combine like terms. We must always end in the form a plus bi. So anything that's not has I the first power, a real part. The real part or the imaginary part could be 0, but it has to have a real part plus an imaginary part, and I has to be to the first power. So here we are going to perform the indicated operation. So this one's real nice because we're adding these two complex numbers. This is one complex number plus another complex number. So we can just add their component parts. So we can say 3 minus I plus 5 minus I. I don't need to distribute that negative. We're going to gather the real numbers here and then the imaginary parts together here. And so that's going to give me 3 plus 5 minus I, and I can combine those to give me 8 plus, or actually minus 2I. And that would be our answer there. We have a real part and an imaginary part. This next one I have to distribute this negative first, so let's do that. So I'm going to have 3I minus 2 minus I minus 5. The I is written first. That really doesn't matter. We'll rearrange them when we do it. So we're going to say this is going to be 3I minus 2 minus I plus 5. So once again, I'm going to have my imaginary portions right here and right here added together, and then my real portions right here and right here added together. So that's going to give me, so that's going to be 3I minus I, and then plus, actually, no, let me do this on another line. So it's going to give me 3I minus I, and I'm going to get negative 2 plus 5. So that's going to give me what? That's give me 2I plus 3. And you can probably write, I would rewrite it as 3 plus 2I. That's how I'd write it, just to have that real part for it. It should take either answer, and I would take either answer, but usually you write the imaginary part second. Next, we have I minus 2 quantity. So I'm going to distribute that negative. This first portion has no real part. It just has an imaginary part. That's fine. So we're going to say I minus, or actually plus 2. I distribute that negative both terms. And so my i's cancel, and so my imaginary part goes away, and I just have 2, my real part. And so you just have to put it as 2. You don't have to say plus 0i. That's fine. For multiplying, we can apply the distributive property and combine like terms, but we must remember that I squared equals -1. For division, we write it as a fraction and rationalize the denominator. Just as before, we must always end in the form a plus bi. So this first one right here, we're going to need to use FOIL on. So we treat it like a normal binomial. If this was like an x and that was like a constant, this is like x, that was like constant, and we FOIL it out. So I'm going to get my first terms multiplied. So I'm going to have 3i times that complex number times 5 minus 4i. So I'm going to get 3 times 5. This is my first terms. And then my outer terms, so 3 times, so plus 3 times negative 4i. And then we're going to say plus my inner terms, which is going to be negative I times 5. That's my inner terms. And my last terms are going to be plus negative I times negative 4i. Oh, running out of room here. Last. And so now I'm going to combine, or I'm going to do all my operations next. And so I'm going to have 3 times 5, which is 15, plus negative 12. Let me start over here. 15 minus 12i. And then I'm going to have negative I times 5, which will give me negative 5i. And then I'm going to have negative I times negative 4i, which gives me a plus 4i squared. I'm going to combine my like terms. And I'm going to get 15 minus, and that's going to be 17i. And then this 4i squared, I'm actually going to take that, and I'm going to change it into 4 times, well, this is going to be I squared is equal to negative 1. I'll just write that somewhere if you forget. So I'm going to have times negative 1 here, so this is going to be minus 4. And so see how that I squared made that negative 4. And so now I'm going to get 15 minus 4, which is going to be 11, so it's 11 minus 17i. And that would be multiplying two complex numbers together. It just works like binomial operations. Only you get to combine what is going to be your last and your first term if you have them set up like this. You have a constant, a real part, imaginary part, real part, imaginary part. Next, we have problem B, 2i times I plus 7. And so let's just distribute that. We don't need to FOIL it out. So that's going to be 2i times I plus 2i times 7. And so that's going to give us 2i squared plus, this is going to be 14i. Well, the I squared again, once a equals negative 1, so it's going to be 2 times negative 1 plus 14i to give us a total of negative 2 plus 14i. All right. That's our answer. Exercise 3, part B. So continuing on to this exercise, we have perform the indicated operation, simplify completely, and now we have what we call a complex fraction. Well, a complex number in the denominator of our fraction. So we have 3i plus 2 over I minus 1. Now I want to make this bottom part a real part. So just to go over something real quick, if we want to get rid of the imaginary part or square part root, what we can do is we call something by multiplying by the conjugate. So if you have a plus b times a minus b, what happens is you get a squared, and then you're going to get plus, or actually minus ab, minus, plus ab minus b squared. So the middle terms cancel out. So I'm going to get the first term squared and the last term squared if I multiply by the conjugate. In other words, I change the sign. So I can multiply by the conjugate of the denominator here, top and bottom, because I don't want to change the value of my fraction. So I have 3i plus 2 over I minus 1, and I multiply both top and bottom by I plus 1, change the sign in the middle, I plus 1. I haven't changed the value of my fraction. Well, now I'm just going to get 3i plus 2 times I plus 1. We'll FOIL that out in a minute. And in the denominator, I'm going to FOIL that out because that was what we're doing right here. That's going to be I squared. And then my middle terms, what is that? Plus I and minus I. You don't have to do the middle part. You can just square each one. That's fine. And then you're going to have negative 1, or negative 1 times 1, which will give you that 1 squared, that negative b squared. And 1 squared is 1. So that's going to give you up top, let's FOIL that out now. So it's going to give you 3i squared, 3i times 1 will give you plus 3i, 2 times I plus 2i, and then 2 times 1, which is plus 2. And the denominator, we got rid of our middle term, so we have I squared minus 1. All right, so that's going to give us what? It's going to give us, what's an I? Up top, we're going to have 3i, and remember this 3, the I squared right here, you can always write it out somewhere on your paper, is equal to negative 1, so that becomes a negative 1 here. And then 2i plus, or 3i plus 2i gives you plus 5i, that's plus 2, all over. Once again, this I squared gives you negative 1, That's minus 1. And so that's going to give you negative 3, and then plus 2, because I'm just grouping those numbers together because they're real numbers, plus 3i, or 5i, excuse me, all over, and this turns out to be negative 2. And so that's going to give us negative 1 plus 5i all over negative 2. You may see written differently. They'll multiply top and bottom by negative 1 to get the negative out of the denominator. It's fine. You can enter this answer fine. But if you want to do that, you'd have negative 1 times the top. So you may see written like this, and then negative 1. Does not change the value of my fraction here. And then so what you're going to get, don't cancel those out, multiply them through, and you'll get 1 minus 5i all over 2. And you can also write it as a real part, 1/2 minus your imaginary part, 5i over 2. You can write that as well. It should take either answer in most courseware. Exponentiation. So we already know that I squared equals negative 1. We can calculate the third and fourth powers, where we have I to the third equals I squared times I. So we just break that up. Remember, you add the exponents. There's a plus 1 here, or just a 1, not a plus 1. There's a 1 there. So if you add your exponent, you get the 3 back. So we have I squared plus I, so it's negative 1 times I, which is negative I. And then I to the fourth equals I squared times I squared, or negative 1 times negative 1, which equals 1. So it cycles through these powers. So you're going to have I equals I squared equals negative 1, I to the third equals negative I, and I to the fourth equals 1. And you just cycle through. So I to the fifth would equal I to the sixth will equal negative 1, I to the seventh will equal negative I, and I to the eighth will equal 1. And so you can just go through this pattern every 4 powers if you like. That's one way of doing it. So if your numbers are relatively small, it's easy to do. You can just say this is going to be, if you count off, so this is I, this is the same thing as saying, well, this is going to be the I to the fourth times I, which is going to be 1 times I, which is I. Here you can say I to the eighth times I to the second, because I to the eighth is going through it twice, which would be 1 times I to the second, and we said I to the second is equal to negative 1. So this would be negative 1. 1 times negative 1. I think that for higher powers, this can get a little confusing. So usually what I do is I tell students to write everything in terms of I squared, because I squared is negative 1. And you just have to divide things by 2. You don't have to worry about multiples of 4. So what I would probably do is I would take I to the 10th and say that's the same thing as I squared to the 5th power. Right? Because I multiply my exponents if I raise something to a power. And so that's going to give me negative 1 to the 5th power. And if I raise a negative number to an to an odd power, I get a negative number back out, negative 1. So that works as well. And you can see the reason why that might be very useful in this next one right here. You can say, you can once again map through the pattern, divide it by 4, see where it is. I think it's a lot easier to rewrite this as I to the 52nd times I to the first. So that gives me an even number, right? I to the first. And so now I divide this by 2, and I'm going to get I squared all raised to the, and then so I divide 52 in half, gives me 26, times I to the first, and that's going to give me negative 1 to an even power times I, and so negative 1 to an even power is 1 times I, and this is going to be I. Another way you could do it is say, okay, well, 53, the closest number divisible by 53, that if I were to divide it by 4, I'd get a remainder of 1. Right? And we did that. We really don't care what it multiplies out to be, because 52 is divisible by 4, which is 13. 13. Now that I think about it out loud. Yeah. The remainder would be 1, so that would be I to the first power, which would give you I back out. That's another way of doing it. Many different ways. I think it's easiest for students to just do it and just write it in terms of I squared, I and I squared, and keep track of it that way. So this, I just divide this in half, this power in half. So 218 divided by 2 will give you 109. So I'm going to say I squared to the 109 power will give me negative 1 to the 109 power. Well, I raise a negative number to an odd power. Well, that keeps my number negative. This one, it's an odd number, so I'm going to have to bring out one of the i's. So I'm going to have I. This is going to be 1002 times I to the first, which will give me I squared. And so 1002 I should say, divided by 2 is 501. 501 times I. I'm going to raise a negative number to an odd power times I. So that's going to keep it negative. And so that's going to be negative 1 times I gives me negative I back out. And so that's the lecture for today. Hope you all have a good one.